I'm Eva Bauer, I'm the Chief Engineer for the Golden Gate Bridge, and I'm here in Guelph, Canada. Guelph is a very beautiful town located about 1 hour away from Toronto. And we are here to observe wind tunnel testing of a scale model of our suspension bridge.
Watching the Golden Gate Bridge roadway rock back and forth is enough to make anyone a little queasy, but it's exactly what Bridge District engineers want to see.
This is an amazing experience.
This wind tunnel testing is in preparation for a vital safety project.
We're making sure the bridge can withstand a major earthquake.
For decades, the Golden Gate Bridge has remained strong through storms, heavy traffic, corrosive marine fog, and the 1989 Loma Prieta earthquake. But experts say an even bigger quake is likely, so the district has been strengthening the mighty structure. Engineers retrofitted the most vulnerable sections first. The North Approach Viaduct in 2001. Then the South Approach structures in 2008. Now it's time for the third and final phase, retrofitting the suspension span. This is the most iconic part of the bridge. It's also the most expensive part of the project, and the most challenging for crews to access since it's high in the air and always open to traffic. Seismic retrofit crews will work from temporary platforms they'll need to build underneath the roadway. To test how those platforms would impact wind drag on the Golden Gate Bridge, engineers hired environmental experts, RWDI, to build an 8-foot model of the roadway deck.
The first thing we do is, of course, we go through a process of verifications. So we make sure the model is exactly like the real bridge. We can dial in any desired wind speed in the wind tunnel and just let the bridge move as it would do in real life. We're mostly looking at vertical motion and torsional motion of the deck.
By creating rough conditions in the lab, engineers will bring stability to the work ahead. They're testing various platforms and enclosures on the bridge to find out what sort can handle high winds and what can't.
To do this analysis is extremely critical because we want to find out what limits we have to impose on all construction, including the installation of the platform, because we want to make sure that at no point the structural integrity of the bridge is put in jeopardy.
We need to make sure that it's performing in a way that's up to today's design standards and it's safe for people, and that it's going to continue to be here for, hundreds of years. So we want a structure that will last and a structure that will be able to withstand anything that Mother Nature puts at it.
When the seismic retrofit is complete, the Golden Gate Bridge will stand strong even when the big one rolls around.